So now this one, I start by getting the center and radius for this. So I'll say now in my solution, I'll be having now you can clearly see that this complex number is going to be a circle. Let my z be x plus iy. Then I substitute here, I'll be having then plus I into y minus 3. That's all equal to 2. Okay, you can see if I apply the modulus, I'll be having now square root of, then this one squared, that's all equal to 2. Then to remove a square root, I have x minus 2 squared, that's all equal to 2 squared. I square both sides. Now you can see this is going to be a circle with the center 2, 3, and then radius is going to be 2 units. If you compare that one with the general, which we say equal to r squared. So if I compare it so, meaning I can start by sketching this one here. This one I'm just going to use a simple sketch. So assuming now here that I'm going to be having my 1, 2, my 1, this, be 1, 2. So now I start by putting my center, which we saw was the 2, 3. So I put my 2, 3 here. Then start my radius was having 2 units. So I count 2, 1, 2. There it's going to pass that also here 1, 2. So this side 1, 2. Then 1, 2. The other side, that's the radius. So in my circle, when I look at the sign, it's less or equal, so the circle has to be solid. So that is going to be my simple sketch. That's going to be my simple sketch. Then I come and look at the other. I come and look at this. Now when I look at this, it's z, magnitude of z. So this one is going to be at -1, -1. That's going to be the center. Now I come and I locate, which is going to be around here. Now to get the minimum, I draw now a line passing through the center and then touching to the circumference like that. So that's what I have. So I can name this. This is our center, remember. It's 2, 3. I have a point A here. I have a point B here. Let me call this one a point D. Now, our least value is going to be the distance dB. Then our greatest value is going to be the distance dA. This dA. So always whenever they ask this, you draw from this locus, passing through the center and then touching the other side of the circumference. So always your least value is from here up to there, shortest part to the circumference, then from here up to here to be the greatest. Now you see that from here up to here is the radius, and from here up to here is the radius. So meaning I know this distance here is 2, and this one is 2. So meaning to get a distance dB, I'm going to get dA, then I subtract off BA because I know BA. I've been having this. So now my dB will be equal to dA minus BA. So how do I get dA? come here and I get but dA. Remember this point here is -1, so we are getting distance between these we are getting a distance. This is -1, -1. So to get dA, I just get a distance, from here up to here is 4. So meaning if I know from here up to here is 4, if I know this one here also, if I know this one here, I can easily get, if I know the distance from here up to here, I can easily get this one here. So now my DC, my distance DC will be equaling to, I get now, squared, and this one will give us 5 units. So mean that now I know what DC is. So if I know what DC is, I can know what dA is. Or in other terms, I can also get this by saying my dB. So my dB or BD or dB can be the same as, I can get DC minus BC. That is the way you can get it. So mean that now my dB is going to be DC, which we have obtained as 5, minus BC, which is 2, which will give me 3 units. So that's the least value. Then we get the greatest. We said it's going to be dA. dA, so to get dA, I'm going to get dB, which is 3, then plus BA, which is 4. Add this and this, which will give me 7 units. Therefore, 7 is the greatest. Then 3 is the least value. So that's how we get those two. Okay.